This is a typical question on principle of moments, and you are to determine the value of the downward force W on the right side of the ruler that is balanced. So we look at the 2.4 Newton force on the left of the pivot. We noted that it will make the whole ruler rotate anti-clockwise, and that's anti-clockwise moment, and the value is 2.4 newtons multiplied by the perpendicular distance. I've used 0.36 meters as the perpendicular distance. It's always good to convert the distances to SI unit, which is meters. Now on the right side you see the downward W, and that will want to make the whole ruler rotate in a clockwise manner. So that is a clockwise moment, W multiplied by the perpendicular distance, which is 0.40 meters. What remains to be done in part A is to again put everything into a principle of moments equation. Remember to write the statement like what I've done, and with that you can determine W to be 2.2 newtons. In part B, even when the ruler has a weight, let's say the ruler is pretty heavy, we don't actually use it in our equation in part A, and you have to explain why. And that is because the ruler, if it's a uniform ruler, the weight is acting at the pivot point. The uniform ruler CG is right smack in the center of the ruler at the 50 cm mark, and that is also where the pivot point is. This means that the downwards weights of the ruler is a force that passes through the pivot. And as we know, if we have a force that passes through the pivot, the perpendicular distance is 0, and therefore it will not create any turning effects at all. In other words, the weight of this ruler when it's pivoted at the CG point, the weight of this ruler doesn't affect its rotation at all, and that's the reason why we don't need it in a POM calculation in this question.